Okay, so we've got here a paratrooper jumps out of a stationary helicopter. So his initial velocity is 2 meters per second. So let's write that. So here he is, right? Let's model him as a dot. Okay, and his initial velocity, so we'll have u is equal to 2 meters per second. Okay, and he's obviously going down, isn't he? So we'll take downwards as positive, right? Because he's falling downwards. Okay, and that clearly goes with then gravity, right? So in this case, my acceleration, when we use that, is going to be positive 9.8 because gravity is going in the direction of positive. So we take 9.8 there, okay? And what have we got here? So let's just model the situation of him going down there. So he falls freely under gravity for 1.5 seconds, then his parachute opens, and of course then his parachute will give some resistance, so then he won't be falling so rapidly. Okay, so there'll be, it says that he descends vertically with uniform retardation for a further 22.5 seconds, right? His speed is 0 as he reaches the ground. Okay, so calculate the speed of the paratrooper just before the chute opens. Well, if I've got, I've got A to be 9.8, we've established that. We've got U to be 2, all right? Now it says he falls freely under gravity for 1.5 seconds. So T is 1.5, and then his chute opens. So we want V, so we just got to use V equals U plus AT. Okay, so V will equal 2 plus A, which is 9.8, times time, which is 1.5. Okay, so if we work that out, we get 16.7 meters per second. Okay, so that's what his speed is when he releases that parachute. Part B then says draw a sketch velocity time graph of the paratrooper's descent. So if let's have a look here then. So we've got here. Let's just think about this logically now, right? As we're working through this. So let's have a look at what we've got here. So we've got velocity along here, meters per second. Make sure you label all that. Time then in seconds. Now at time 0, okay, he gets released, doesn't he, from this plane or whatever he's been released from. And the speed, if you remember back up here, is 2 meters per second, right? So say we'll put 2 here, okay. And his speed will increase, won't it? His speed increases over 1.5 seconds to 16.7. So we'll put 16.7 here. Don't worry about the scale. Remember these now. It's just try and get it looking reasonably accurate, but it's not the deal here, right? At the end of the day, we need to just sketch it so that it looks realistic, okay? Reasonably realistic. Obviously, we can't get the scale perfect. Now, for 1.5 seconds, okay, it increases its speed, the parachutist. So 1.5 is about there. Okay. So he increases his speed there to 1.5 seconds to 16.7. And then he opens his chute. And what it says then? He descends vertically with uniform retardation for a further 22.5 seconds. So 1.5 add 22.5 takes you to about 24 seconds. And it says he descends with uniform retardation. So that means his velocity now is reducing until 22.5 seconds further along when he reaches the ground and the speed is 0. Okay. So that's why we can finish down here. So we've done that and everything's mapped out perfectly there. So part C then, it says calculate the height of the paratrooper above the ground when he jumped out of the helicopter. So really what we need, if you think about it, the velocity time graph is going to help us, because remember the velocity time graph, the area, okay, the area gives us distance, isn't it? And this is the distance he's fallen. So we just need to work out the area under the graph, okay? The distance fallen will be the area under that graph. And I'm thinking of splitting this up into two parts here, so we can think of that as 1 and 2. So area of 1 is a trapezium, okay? So half 2 plus 16.7, okay, that's 2 there, 16.7, times then the height between them, which is 1.5. So we work that out. We get that out to be 14.025. And area 2 is just a triangle, yeah? Half times base, so that distance there, which was 22.5, wasn't it? Times then the height, which is 16.7. And that comes to 187.875. So then we need to add those two together, don't we, to get the total distance. So I add 14.025 on that. I get out then my total distance is fallen to be 201.9 meters.